Edge Native, bringing the cloud-native development and operations experience to the edge. I'm Frank Brockners, Distinguished Engineer for Cisco. So, where do we start off? We start off with an industry in transition. Back in 2010, all workloads were literally residing on-prem. Then the cloud appeared. And with the cloud came a very simple operations model. And we've seen loads of people move their workloads from on-prem into the cloud. And since around about 2015, we see the pendulum slightly swinging back again. We're beginning to see that the cloud operational model is great for certain cases, but not for all of the cases, which is why you see the pendulum swing back. So why is this? First of all, there is privacy and regulations, and privacy and regulations today are more fierce than they were, say, in 2015. So the key word here is something like GDPR, where you have to deploy certain workloads in a country on site. Same goes for security reasons, where people want to go and have their data be residing on site and be processed on site. In addition to that, there's all the typical performance aspects. As soon as you're no longer able to afford sending the data to the cloud and back, because that incurs hundreds of milliseconds of delay, you're in the edge game. That is AR, VR, that is autonomous vehicle. Whenever the control loop needs to be really quick, like to a robot, you need something at the edge. And then I think another big trend is the ultimate reason of cost. People found that the cloud is not for free, nor sending data to and from the cloud is for free. And that bonds with a growth of data right at the edge. And a key reason for that is the ability to do AI, ML right at the edge. Say some 3-4 years ago when we were discussing edge and AI, we hardly kind of saw that bonding. These days, roughly 50% of all the conversations that we're having at the edge are including AI and ML, and we expect that to be 100% shortly. So AI, ML, and edge, that's a match made in heaven. So that is, I think, one of the driving forces why we see so much interest in edge. While we are moving all the workloads now, or a load of the workloads back from the cloud into the edge, there is one thing that people want to go and preserve, and that is the development and deployment experience. The cloud is so simple. So the question is, and that's the edge native question, can we make the edge feel like the cloud from a development and operations perspective? And what does that mean? The edge needs to be easy. So we want to go and hide the edge's complexities, the specifics around the edge, like being resource constrained, being on-prem, being location aware, being with fierce policy control. We want to go and get something that deploys as fast as it deploys in the cloud. So deployment in seconds or minutes, as opposed to what you typically see with edge deployments, where you got to go and send a man in the van in order to deploy. But all of that, please, with a familiar tool chain. So don't give me yet another tool chain to learn, but I want to go and leverage what I'm already used to from a cloud deployment perspective, which is like cloud experience at the edge. So, I said edge multiple times. Which edge? If we follow the Linux Foundation taxonomy, there is multiple edges, right? So we have the very constrained device edge at the very left-hand side, smart device edge, on-prem data center, all the way to centralized data centers. And there is two trends that we can go and see. We can either approach the edge as something that is just an extension of the cloud. And that is what Gartner, for instance, calls cloud out, where we're saying, well, we can go and expand the homogeneous DevOps cloud operating model, which is assuming resource-rich environments all the way to the edge. And that caters up to a certain limit. Whereas if we're starting from the other end, which people refer to as edge in, is we're embracing the need that, well, we are location aware. We are dealing with heterogeneous environments. We are dealing with resource-constrained environments with constrained connectivity where bandwidth is not, well, in abundance. And where we're also dealing with a user set that is locally on site that is not a specialist in IT. It's a specialist in the art that happens at the edge, but not in a particular IT environment. And so I think, where do these two meet? Where is the operational model of cloud no longer applicable? And what we identified is it's really around the smart device edge and small on-prem data centers, where smart device edge means small user-facing compute. So where does it apply? It applies with your favorite coffee shop, where you need to go and, say, render something on a local screen, where you need to go and play local music, where you need to go and optimize, say, the journey of the protein through the kitchen, where you need to go and send information to a particular assembly line in a factory environment. So those are the environments that we're speaking of here. So from cloud native to edge native, what does that mean? It largely means that we have to go and take a step back and evolve what we're also familiar with, the 12 factors. Back in 2011, the Heroku people gave us these 12 factors, which are still relevant, still there, very stable. So more than 11 years in, we still see that as something that is state of the art from a kind of, how do you deploy something cloud native? Can we evolve this very stable set of principles, into something that is edge aware? Yes, we can. And with that, we need to go and evolve these 12 factors around code base, dependencies, config, backing services, all the way into logs and admin processes. And what we need to go and do there is, well, we need to go and amend those largely with the concept of location in mind. So number 2 evolves into dependencies and policy, where we need to explicitly declare and isolate dependencies and policies across edge, local, and cloud. We need to go and define backing services, where we need to go and define backing services attached potentially remote resources, location aware. We have to go and define a new principle for scaling. We're not only scaling by processes, but we're also scaling by sites, which is probably the biggest change here. And sites can be disposable. And then we have to go and do a load of things for logs that we're not going to go dive into. But I think for logging, we have to change from logs to metrics, and then be smart about filtering metrics so that we only elevate metrics that matter. So don't push data from the nodes at the edge because they are low bandwidth, but push information from these nodes. And that is a self-supervised learning effort. So let's dive into a few of these topics more explicitly. So one is around concurrency and scale, where the location concept really factors in. Historically, we had workload diversity and scaling the number of processes by the needs of that particular workload. That's what we're familiar with from a cloud perspective. What we now have is we need to go and deploy things across thousands of sites. And we can't really treat every single site as a pet. We have to treat these sites as cattle because we're trying to go and deploy cookie cutter. So we have to go and keep in mind that we're not scaling by process only, but we're also scaling by site. Within a site, we scale by process. And then we scale across sites. There is another dimension here. And sites, what are sites? Sites are an abstract notion of a location. So in broad terms, typically you would associate a site with a particular location. So be it the location of your favorite, say, coffee shop, or your favorite restaurant, or, well, your location of a particular outlet of your factory. But it could also be another grouping, like it could be the grouping like the development team. So it's not necessarily only restricted to physical geolocation. We can go and expand that. And whenever we deploy something, we're deploying applications on these sites. We don't really care if there's multiple nodes, if there's clusters, where do they land on? Because we care about running a particular application on a particular site. And when it comes to disposability, I already mentioned that sites and their nodes, we need to go and treat as disposable entities. They can fail at any point in time, much like processes. So if they fail, we'll restart. We will never try to go and debug a node state. We'll never try to go and debug an edge cluster state. We'll never ever try to go and debug a site state. We'll just start over. That means like what you have from an operational principle perspective is either hit the reset button to factory reset or flip the power switch to go and power on again. And then you might want to go and rebootstrap the node or the entire site. That's the maximum that you can assume from somebody that is not skilled in the art, but still operates this on-site at a particular location. From a backing services perspective, so backing services are attached, potentially remote resources. So the old principle about having deployed dependencies explicitly articulated still holds. But these dependencies can be remote. And every single location, every single site needs to be empowered to instantiate these dependencies. So a site in its behavior will be autonomous. Once you declare the dependencies and tell the site about the dependencies, it needs to be able to instantiate these dependencies and render these dependencies individually. When it comes to backing services, we can't rely, and that's where cloud out as a principle really breaks down. We can't assume that the cloud can reach a site. Most of these sites that we've seen, especially where the smart device edge happens, they are like located in remote locations. They might be connected over really spotty connectivity. We had one customer of a large quick service restaurant chain, and they said roughly 1% of my sites are always down. Obviously not all the same set of locations, but well, there's tens, hundreds of locations that might be down at every point in time that we have to go and adhere to. So connectivity can be loose. The cloud can't reach the site, but in most of the cases, we can assume that the site can reach the cloud at least every now and then. Even if it's kind of mounted on a bus, the site, or if it's an autonomous vehicle or the likes, every now and then, the site will be able to reach the cloud. So we can go and pull from the cloud. We can push to the cloud from a site's perspective, but don't assume the reverse. And that, I think, limits a lot of the off-the-shelf solutions that we see from where you have the control center all the way in the cloud, and then you just push things as an extension of the cloud to various edges. So let's look at how like edge-native concepts could be deployed from an operations and deployment perspective. And let's go and do this with our, well, favorite of the day, which is Kubernetes. Like if we look at Kubernetes from an oversimplified way, we have an API server. Via that, we insert state into the etc database, and the individual workers will fetch the state and realize the state from the etc database. So clusters are pets, workers are cattle. They can go and fail, as we know. Now, if we go to Edge Native, we transition to like, we make clusters or groups of clusters the location, the site. And then, well, we scale by site. And now suddenly clusters are cattle and they can fail at any point in time. So we've got to go and be kind of cognizant that that might happen. Controlling them, we can go and adhere to the same principle as Kubernetes. We have a global API and we have a database that we host the declared or desired state in. Some people could go and call it intent. And then these individual sites will have an operator that fetches the declared desired state and realizes that state locally. And then they push updates on their individual status, hopefully filtered down to few metrics so that we're not overwhelming the uplinks because they're typically like relatively narrow band. So does this work? Yes, we've built an experimental system we call Great Bear, which I'd briefly like to introduce to you here. It's apps at the edge as a service. We are kind of in a trial phase right now, so you can go and get your hands on. Later on, I can refer to you to a blog that has more details, including like a link to a sign-up page where you can go and work with that. So what we've built is, we've built a system along Edge native principles. And we've built it on top of a lightweight version of Kubernetes. Why? Because we want to go and adhere and leverage the cloud toolchain as much as you can. So if you're familiar, the stepping stone from cloud native to edge native is a very, very small one. So let's go and take an example. So let's take a persona and say, well, we want to go and roll out a new site and deploy a new app. So just remember the concepts. We have apps, and these applications are deployed to sites. And sites are just groups of nodes, or app nodes like we call them. Small computers, all the way up from a Raspberry Pi. It could be NVIDIA Jetsons, larger ones like x86, Intel NUCs, all the likes. So here is an example, the smallest example that I can go and give you. It's my Raspberry Pi. And let's assume that I booted it up with an OS, and I have the Great Bear agent already installed. And that Great Bear agent will now go and check back with a centralized control plane in the cloud and try to find out what is my desired state. And let's recognize the serial number that I have on that little device, because I need to have that in order to go and claim that device as mine. So we'll go through the process of defining a new site, add an app node to that site, and then deploy an app for the fun of it, so that you see like, well, we can make something useful with it. So login into the thing. I have a demo account here set up for you. And if I go into that particular demo account, I see like I have a few locations set up in London, Paris, Roll in Switzerland, and a site in Hungary. What I don't have is, well, a site in Germany. And well, let's go and create that site in Germany. I live in Cologne. So Cologne is another site, and it's Frank's home office. And well, by now you can also find out where I live. I live in Gutenbergstraße 26 in Cologne, Germany. So you can now send me nice postcards from all over the world. I click on apply, and I have my site applied and there. But well, there's nothing. It's an empty shell. I need to go and associate a node. And let's go and register the node that I bootstrapped prior. We now need to remember our sequence serial number, and we give it a name. And I give it a little description. It's my Raspberry Pi. It's a 4B with 8 gig. So I have my node, and now you see it initializing. That takes a second, depends on the speed of your Raspberry Pi and your overall environment. So it's installing now a local cluster. It's electing a leader, and boom, here we go. Now we are up and running. We're ready. We are successfully started, as you see in the status balloon there. Last thing is we need to go and deploy an application. And if we go to our deployment catalog or app store, there is multiple apps that we have right now as seed apps, like simple MQTT message broker, a distributed AI runtime. And one thing that I want to go and focus on here, which is event-driven display, which is a tool to render content at the edge. And in order to do this, I need to go and give it an API key to interface with my cloud control plane. And I also want to go and enable a VNC server so that I can go and show you the screen not only via a camera in my backyard, but also we can go and VNC to the thing so that I can go and show that more easily in this particular demo. Then we click deploy, and now the thing fetches the intent and starts to realize this intent locally on its particular node. So we have it up and running. We see event-driven displays there. Checkbox, and we can also go to particular deployment details if we're interested in that particular deployment set of deployment details. And once we zoom out again, like you see, well, my node in Cologne, let me go get rid of this thing on the side, is up and running, and I have an application deployed there. Great. So fantastic. We've deployed something. Probably right now you're kind of curious. Let me go and kind of sidetrack a little bit of what have I deployed. Event-driven display, render and display content locally at the edge for digital signage and video surveillance. So we basically render streams of information, RTSP streams or web information, and show that on a local HDMI port of my little Raspberry Pi. Typical function that you find all across. And just to go and show you an example of what we can go and do with this app, I'm going to go and show content, render cisco.com as a web page to 3 locations, Budapest, Cologne, and Rolla as I had it deployed, so including my little Raspberry Pi that I just bootstrapped. So in a dashboard, we're going to go and specify what content to which locations. We're saying, well, to 3 locations, we're going to go and roll it out, and we're going to go and deploy cisco.com. And then these 3 locations, again, Edge native, will be empowered to reach out, fetch the content, and render it locally on their screens. So from a demo perspective, left-hand side, you see the control panel that we have with the nodes in London, Paris. On the right-hand side, you see VNC connections to the 3 nodes that we want to go and deploy to. And now I switch one of the views to a look over my shoulder. I did that recording with a little GoPro. So right now we're choosing that we want to go and run content or render content to 3 sites, Budapest, Rolle, and Cologne. And I'm going to go and then say, well, I want to go and bulk update the content to these 3 sites, and I need to go and hit the button and input the URL. This URL here is cisco.com. Yeah, I work for Cisco. So let's render that. We sent the info, and then you see that these individual nodes will reach out. And the 2 locations, Budapest and Rolle, go first because they are VM-based deployments. And my little Raspberry Pi, like you see on the right-hand side, takes a little longer to render, but it's only slightly behind. So fun thing, we deployed an app and actually used it here. So there's more apps, right? So token services and development. So how can we apply Edge native to more of a kind of application developer view? So we've seen fast deployment in seconds rather than months with this EDD thing. But let's focus a little bit on kind of hiding the edge complexity, abstracting them away, and leverage familiar tool chains, and so that we can go and dovetail with what you've done in the cloud, say from an AI model training perspective, and just deploy the model, and the edge infrastructure, the services that are running on the edge are abstracting away from you, that the edge has little resources, little memory, and might not even be capable enough of running one model on a particular node. So when we talk services at the edge, there's more. We talked about content rendering, edge data rendering. You saw the EDD example. You talk about data management, kind of workflow and pipelines, even storage at the edge. But what I like to go and focus on here is the edge AI aspect, given that there is so much around that. It's about fitting a model to the edge nodes for inference to make sure that, well, the need from the model matches the capability set at the edge. And it's also things like federated learning. So let's put ourselves into the shoes of a developer. I have developed 2 no AI models. And, well, the first one requires 100 meg, but that's too large to fit on any of my nodes. Bummer. The second one I developed runs at 2 frames a second, but I need to be running at 5 frames a second. And, bummer. So why is this kind of relatively important, the frames a second, for instance? Left-hand side, like if I run at 2 frames a second and want to go and detect people at an entrance door, I might detect 5 people like on the frame on the left-hand side. But in reality, there are 6. And I would be able to go and spot that if I'm running at 5 frames a second and not 2. Because you see, like, certain persons are overlapping, but sometimes they show up. Okay, cool. So how can we solve that particular problem? And how can we solve with the problem at the edge with resource constraints? The first thing is you can go and throw hardware at this. Let's just buy a bigger node. Okay, check. We do this. We have built like Meraki cameras with a load of compute to go and run specific models. But even those ones are maybe too small for certain use cases. We see that all across, especially if you take an off-the-shelf YOLO v5 model, it's more than 100 meg. And if you do transfer learning on that, you easily end up with models that are very large in nature. The second thing is, well, what you typically do is you compress the model. So nobody runs models uncompressed. You use them and go through a toolchain where you quantize, where you layer reduce, where you do infusing of operators to go and make that model smaller and perform better. But sometimes even that one is not enough. And I'd like to go and take it into a domain where we go even one step further, where we say, well, we have a distributed environment at the edge with multiple nodes. Let's use it. We can go and split the model into multiple parts and then run multiple parts and fuse these parts later from an overall output perspective so that we can go and distribute the model over multiple nodes and that way increase performance. So the idea is very simple. So we take a model and we split it so that we run the first couple of layers on one node and the second couple of layers on another node and the third couple of layers on another node. And finding that split is a non-trivial thing. So you need to go and consider the network bandwidth. We found that in many cases, like the network bandwidth is actually a constraint. So you need a fairly capable network between the nodes, like a gigabit, because, well, the node layers, the layers of the model communicate quite a bit. And so you need to have a high bandwidth network in between. Computing a proper split is an NP-hard problem. But luckily, you can come up with heuristics if, well, the number of nodes is not too large. And that's what we're doing, right? So we compute an optimal split between the two to go and arrive at a particular service level objective, like a certain frame rate, as we've seen with 5 frames a second. And here's the results of an experiment. Like if I'm running on a single node, left-hand side, and it's an Onyx model, I can run at, say, roughly 1.1 frames a second. And that's just kind of colleagues of mine floating into the office. If I split it, I can go up to 1.7 frames a second. Why doesn't it exactly double the number? Well, there is a bit of an effort that every node needs to go and take to split it and then pass it along. But you can get better if a particular node is optimized to run a particular runtime. So if you have a node that is optimized to run, say, T of light, because it has a special coprocessor, you can absolutely do what we're seeing on the right-hand side. And while the splitting, as you see, can even be done in a mixed fashion, where you're not only splitting, you're also mapping the parts of the model to the optimized architecture that you have running underneath. So splitting is well worth to go and give us a bump in performance above and beyond throwing hardware at the problem and doing model compression. So with this, we no longer need to go and do what we historically have done. Historically, if you are not meeting the mark from a frames a second perspective, we typically sacrificed accuracy. So we went to a simpler model just to go and keep frames a second up. With this, we don't need to do that anymore, right? So if we split, we can do better. The other question is, and I mentioned that early on, like, so inference is one piece, but what about training? And, well, model training, or more specifically, federated learning, is a brilliant case for our edge native deployment concepts. So I'd like to train an AI model, but I can't get access to my customer's data. Well, let's do federated learning. So what is federated learning? So I have a set of locations, and these set of locations have private data available. So customer location 1, private data 1, and so forth. And you have a centralized model, and that global model you want to go and use at these locations and do transfer learning for the individual data sets that you're coming in, and just consider say a healthcare case where you have patient data coming in for a particular hospital, and you don't want to go and relay that data into the cloud for sure. You need to go and keep it local. So what we can go and do is we can distribute the global model to have at every site a local model. Then we train that local model with the local data. And on top of that, well, we just use it and update not the data to the global model, but we update and say, well, the local weights, the local accuracy, and the likes of what I achieved here is the following, and I use this to update the global model. So in order to facilitate that, we've created a framework called Flame. It's there in open source, which is there to compose and deploy federated training workloads easily across many edges. So very useful framework, and guess what? It fits edge native really well because of its principle, right? So you push to the cloud, you pull from the cloud, and you keep the data local. Very straightforward. Pull the global model, push the updates, and keep your data local. And we've built a little app around that, so it obviously runs on this experimental platform that I mentioned earlier on. So finishing up. So Edge Native enables a Cloud Lake experience at the edge. Awesome. It also enables a transition. Because historically, if I look at the edge, and especially the smart device edge, we had loads of point solutions. So if you look at what happens today in, say, a retail store, you have a smart mirror, and the smart mirror is built as a single trick pony, I would like to say. So you have hardware, software, operating system, all tightly integrated to deliver one thing, and only one thing, a smart mirror. Or you'll have loss prevention solutions to go and see whether people indeed scan the product at self-checkout. And it's all dedicated to one particular problem. So buy a piece of hardware, piece of software, all tightly integrated with its own management system. And that's okay if you have one or two solutions. But what we are seeing right now as, say, stores are getting digitized, people do something for loss prevention, for behavioral analytics, for people counting at the front door, for smart mirrors, for digital signage, and the likes. So what do you do in that case? Well, you need to go and think and start over, because, well, this is not maintainable if you're having a dedicated solution one at a time, nor will it, well, evolve with the speed that you need, because if a new solution comes in, you don't want to wait 6 to 9 months to roll new hardware. So this calls for a platform approach, where we have an operational layer, an edge-native operational layer, and we have edge-native services on top that help me abstract away the complexities of the edge so that I can go and deliver a cloud-like development experience to the people that build smart mirrors, loss prevention solution, and the like. So they can really focus on building a solution as if they were in the cloud, and then we can roll things to the edge really easily. And I think this is really what Edge Native gives us. It's a new principle to operate things at the edge. If you like this overall discussion here, there is a little bit more detail that I wrote in a recent blog. So if you go to eticisco.com/edge-native, you can learn about what we've been discussing in this particular session today, a little bit more in detail. And there is also a link to go and sign up for this kind of early trial demo system that we're going to go and open up at one point to, well, everybody here, so that we're making this a service available on the internet to everybody. And with this, I'd like to thank you, and I hope that you enjoyed the session and you have a great day.